Now I just need a friend. Hello everyone. So it's been a long time coming, but I'm finally ready to show you what I've been working on. So it's taken a long time to get to this point. I'm really excited to share with you what I've been doing. So as you know, up until this point, I've been working on my Bluetooth mod that was powered the PS Placeable that Dan built. Really fantastic bit of kit this, and that's what powers it. That's what makes it work. But this isn't very portable. And the goal I always wanted was to be able to use Bluetooth controllers and things with your PSP without doing anything to it. You know, as long as you've got custom firmware, I wanted to be able to use the controllers with it. So what I've been working on is a way of interfacing with the PSP via this little socket here. I don't know if you can see that. So that is the TV out connector. It's the AV port. It's what allows your PSP to hook up to a telly. But it's also what allows the PSP to use the media remote to change music and things. And that media remote actually communicates with the PSP digitally. And I can use that same communication to talk to an ESP32 or any other microcontroller. So what I've built is like a development board that allows this to talk to that. So therefore, this can talk to them. And you see where we're going with this. So I figured we'd talk about that today. So before we get too far in, I want to share that this video has been sponsored by PCBWay. They did all of my PCB prototypes for this project, and they're absolutely fantastic. They do all sorts of different services. You know, you can do PCB designs like this. They do assembly, so they assembled all those parts. They do flex PCBs. They do flex rigid PCBs. All sorts of options, all sorts of colours. You know, really, really cool stuff. And a little bit further on in the video, I'll be talking to you about how to make them yourself, going through their services. They've got some really good features that I haven't seen others have, so that if you're designing your own PCBs, it's like a one-click solution and it's all uploaded and all ready to go. So yeah, really cool stuff those guys are doing. So, but anyway, let's have a demo, I suppose. Right, so the first thing to know about this is it is a tech demo. So the functionality you'll see here isn't something that every single game will be able to use. So Homebrew will be able to use it if the developers choose to implement these features, but any normal games or the XMB won't be able to make use of all of this stuff. This is to show what could be possible if people wish to use it. And I've got another camera set up. I don't know if I'll use it in the end video, but just to show you, using the controllers from another angle, because I don't know if being straight down will work. So let's open up the tech demo and I'll show you what's what. So when that loads up. So there's a few different features on display. So the first one you can see there is a ping. It's essentially a way of the PSP knowing that this specific device is connected rather than any other serial device. So if we disconnect that, you can see it instantly goes red. It knows it's been removed. If I plug it back in, it knows that this specific device is connected. So if we move on, so what this is demoing is it knowing which controllers are connected. So what it's done now is it's put the ESP into pairing mode. So it would now accept new controller connections. So if I put the DS5, DualSense, whatever it is, into pairing, it's now connected. You can see we've got a little image of a DS5. So the PSP knows what specific type of controller is connected, because obviously the DS5 has extra functionality that maybe a Switch doesn't in terms of its LEDs and that sort of stuff. And it also knows the battery level. So if I then connect the Switch, it can support up to 4 controllers. I'm only using 2 for this demo. It knows, that's a Switch controller by the way, it knows that you've got a Switch connected and 50% battery. So if we press start, these are the series of tech demos that we have. We have a very basic implementation of Pong, which was very helpful thanks to AI. We have player indicators, we have color and vibration. So let's do player number first. So what this is doing is, you know how you have the little LED there, and you have the one on the bottom of the DS of the switch. It allows you to control that. So if I press X, it cycles through them. Look, 1, 2, 3, 4, and off. And the same on this one. This one does it a bit differently because it's using bit masks, and the switch handles the various bits in that mask slightly differently. So you would have to have code to handle the differences between controllers, but you know what type of controller is connected, so you can deal with that. Yeah, nice and simple. The next one is color. So controllers that have built-in LEDs, I think it's just the DS4 and 5, you can control them. So I've mapped the analog sticks to the different colors. So the right analog stick is the green, so if you've got off or fully on. The left one, the X axis is the red, and the Y axis is green. So you can see we can control, I don't know if that's coming out all right, the colors, and this is, as you can see, this is quite smooth. This is updating every frame. Yeah, and obviously it's waiting, because obviously there's a delay in sending the communication. So it's not, you know, and well, yeah, it's quite smooth. The next demo is vibration. So this is quite cool. I don't know if you can hear that, but I'm controlling the vibration in both controllers based on the analog sticks of this one. So if I turn it off, because I don't know if that came through in the camera, but basically we have a weak and a strong motor that most controllers have. And if you can read that, you can see that I said the switch didn't have it, but I've since realized it does. So the left stick controls the magnitude of the weak motor, and the right stick controls the magnitude of the strong motor. But what's quite cool is, I don't know if you can hear it, you can almost make music with it. If I can get it at that right sort of resonance where it doesn't vibrate the table. Obviously, when I come to play this back, I realise you can't hear any of this, and I'm just looking like an idiot. But and again, that's really quite responsive. You know, the vibration isn't a delay. You know what I mean? So you could, I don't know if you've ever played the Ratchet and Clank games on the PS5, but there's a scene in there where you're in a nightclub and the music, like the vibration that you'd feel in your chest, is being played through the controller, and it's a fantastic effect. But you could build something like that with this because it's that responsive. And the way that's working is it has a built-in delay. So when in the homebrew, when you give the command to say, play this vibration, not built-in delay, built-in duration, you can say how long you want it to last for. Because if your controller disconnected or you lost a packet when you're saying turn off the vibration, you could potentially have the vibration on forever. So with this method, no matter what happens, the vibration will always turn off at some point, which is what you want. So if we go out of there, and lastly is Pong. So it's very simple, but this demo is to demonstrate the use of multiple controllers, and we have the full controller data for both of these controllers, so we know all of the buttons, all of the analog sticks, both of the triggers, for both controllers. Yeah, and that's it really. So in terms of the triggers, these are just buttons that are on or off, but with the triggers, there's two types. You can either have on or off, and you don't really have any control over how far before it considers it to be on, but you've also got analog, so you have a range of 0 to 255 based on how far you've pushed them in. So a homebrew that wants to use it can choose which one they want. And that's it really for the demo. So let's talk a bit more about the hardware. We'll talk about how it's made. We'll talk about PCBWay and how you can have your own made. We'll talk about the future of it, because this is a development board. This isn't the end goal. And talk about how you yourselves can start playing with this if you want to. So yeah. Right, yes, so the hardware. So this is the third time of me recording this, because the first time I didn't do the audio, the second time the autofocus didn't work. So you're probably getting the worst version of it, but there we are. So what you're seeing here and what we've seen in the demo is like a development board. It's what allows me to build the hardware, the firmware. But this sample is available on my GitHub, this entire design. but I also have another design which is just like a breakout board of the connector, so you can solder a cable to it and there's literally just a tiny little board for you to do what you want with. But the idea of the project that I've built was it's like a library for other homebrew makers to make their own designs with. So this connector, which plugs into the PSP, and the footprint for this connector, which allows you to use AV cables, are provided as a library that other people can pull into their own designs and use on their own boards. But like I said, I do have this and another design as a sample for if you just want to make your own stuff, you don't care about the board, you just want to play with the PSP, you can just use one of these straight off the bat and off you go. But before we talk about PCBWay and how you can actually make them with them, there's a few little caveats you need to know about. So the PSP operates at 2.5 volts or 1.9 depending on the model, whereas the ESP is 3.2 volts. So you need a logic level converter to convert those voltages. So this design has that built in, that's these bits here. But obviously if you're building your own design, you need to be aware of that. And the board thickness needs to be 1.6 millimeters. And you need to bevel the edges of this connector. So when you order it, they'll be perfect 90 degrees. I'd highly recommend you put a slight angle, a slight bevel on them so that you don't risk damaging the pins in the connector. I mean, it'll probably never happen and never damage, but the one time you don't do it, it will. And the last caveat is if you are doing something where you're using the AV out connector and you just plug it in like that and then plug your connector in, the PSP will refuse to acknowledge you have that cable connected unless you also have a headphones cable plugged in. It's a really stupid design, I don't know why they did that. So that's what this headphone jack is for. So that connects directly to the AV socket. So you need to use like a patch lead to connect from there to your PSP. The serial doesn't care, you can still use the serial without it, but if you want TV out, you have to have the audio hooked up as well. So it's a stupid design. Right, so third time's the charm. Let's see if this video came out any good, and we're going to go and have a look at actually making it with PCBWay. So I really do enjoy their services. It's really cool, some of the stuff they offer compared to others. So yeah, let's go and have a look at that. Right then, so let's begin. So the first thing you want to do is you're going to go over to the PSP Bluetooth AV connector repository. So this is the one that contains all of the hardware that I mentioned. And if you go over to the releases, you can see here we'll have a release. So this is the latest one currently, but there might be, you know, other ones in the future. But they will both have, well, and all of releases will have a library zip file and a samples zip file. So what we're concerned about at the moment is the samples. That's the breakout board and the dev board with other components in it. So I'm not going to talk about the library today. That's documented, and you can see in the release it says where to go for that. But in the future, I might do another video on that. So if you download the samples zip, and then you want to unzip that, and now I'm in Fedora, so it will obviously be different if you're in Windows or whatever. But inside here, there'll be two folders for each sample. So the breakout will just have a Gerber's zip, if I've pronounced that right, and that is all of the files necessary for them to know the position, the shape of the board, where the traces are, all that sort of stuff. Whereas the dev board will have the Gerber's as well, but it will also have a BOM and a positions file. And these are the bits that tell PCBWay what components you've got on it, what resistors and whatever, and where they are on the board. And I'll show you what they do in a minute. So with all that done, you go over to PCBWay and click on Quote Now. So we're gonna go to the Gerber upload files, where you can give them the Gerbers and it will work it out itself. I'm not sure if I'm pronouncing that right, but I think you say Gerber. Anyway, you select the file. So what we're going to do is we're going to go to the folder that you created, and I'm going to show you the process of the dev board, but the AV breakout is the same, other than the assembly, because there's no components to assemble, whereas with the dev board there's assembly as well. So that's the better example. So you select the Gerber's zip file and let it load it up, and then you should see a representation of the board. So all of the defaults it's selected you can leave alone, except for the thickness. That's the really important one. You need to make sure that that's at 1.6. It should default to that, because that is how thick it needs to be for the connector inside the PSP. And you can do other things, you can change the colours and stuff. It's worth noticing that the colours, there's standard colours, which you don't get an extra charge for, and then there's like advanced colours, which you will get an extra charge for, I believe. And then if we go all the way down to the bottom, we want to tick this assembly service button. And so there's different modes. You know, you can do the ones where you let PCBWay find the parts for you, but you can also do it where you give them parts, or you have a mixture of both. But I always do it where just let them find them. And you want to say how many there is, so you just put 5 in there. 5 is sort of the standard amount, I believe. Multiples of 5. And then with all of that, everything else can stay the same, and you will click on Save to Cart. You can change here where the shipping, where you're shipping to, and what shipping method you want to use, so you can get a guesstimate of how much it will cost, but you can change that later on in the process. It's worth noting that the price you see at this point does not include the cost of those parts. In the next step, we will upload those extra 2 files that I mentioned, and then there'll be another process where we'll find out the final cost, but we'll come to that next. So we just go through this. So now that will be in your cart and under review. So that means somebody at PCBWay is going to review the uploads you've done and review the BOM and make sure everything's fine. But we need to upload those BOM file and position files. So we click on this Add File button. And then we need to upload the parts list, which is the BOM. So we select our BOM from the downloaded zip. And we need to upload the centroid file, which is positions. That tells it the orientation and the position on the board of those components. And then we click Submit the file. And then we're done. So what's going to happen now is if someone at PCBWay is going to review this, they're going to look through the parts that you've asked for in this bill of materials file, and then they're going to contact you with a quote, essentially. So that will be the price you saw on the previous page, including the individual parts cost of all those individual components. So you'll end up with a total amount, and then at that point you can say, yes, I want to go ahead and pay for this, or you can say, no, I want to I don't want to go ahead, that's too expensive, or whatever. Right, so we've sorted out the hardware, but on its own it ain't going to do anything. So the next job is to get firmware onto it, and we have a repository with the firmware lives in called PSP Bluetooth firmware. So you might have seen it other parts of this video called PSP Bluetooth dongle, because that's what I originally called it, because the idea was this was going to be an external dongle. But then I thought, well, it might not be. You know, it could be made internal, it could be in a Nintendo Switch style dock. So I decided to make it a bit more generic and just call it firmware, because technically that's what it is. You don't care what the hardware looks like. But if you go over to releases, and currently it's all sort of in pre-release. I'm still sort of figuring stuff out. So you can see here we have a number of release candidates. That's what the RC stands for, release candidate. And once this is sort of finalized, it'll become a full release and it won't be marked as pre-release anymore. But if you just select the most recent one, and inside of here there's a few different binary files. So if you've used or seen my Consolizer project, you'll realize there's a web app I've built. And I'm going to do the same for this, but right now that doesn't exist. So you're going to want to download the merged one. So this contains all of the individual binary files all merged together. So if you download that. So the next job is to actually flash it onto the ESP. So you could take any of these and use whatever tool you prefer, but there is a tool in the browser you can use that is provided by the people that make the ESP, but you have to use it in a Chromium based browser, because otherwise the other browsers don't support the technology needed. So if we go to the ESP tool, I'll stick a link to this in the chat, in the description. So this is the tool that will program it for you from your web browser. So first we need to connect. So some modules seem to struggle to connect automatically. So I've had to press the boot button whilst I'm connecting to get it to work. So just if it don't work first time, try doing that. So you click the connect button, and then I'm on Linux, which is why you see so many extra serial ports, but you select the serial port that it's on and press connect. And you see you got this failed to connect to device. That's because I didn't push the boot button. So I'm going to try again and reload the page and try again and see if I can get it to connect. See, now I pushed the boot button whilst I was connecting and it's worked. So now what we need to do is we need to select the file. So we need to select that binary file from the download folder, from where you downloaded it. And the next thing we need to do is change this address. So you can think of the address as the point in memory that we're going to flash that binary file. And we want to flash it right at the very start. So we do 0x0. That is basically saying flash this right at the beginning. And then you press program. And if we look down here, we can see it's flashing it. So once that's finished, we'll give it a minute. There we go, nice and quick. So to test that this worked, if we reload the page, and this time we open up the console. So we click start, select the same USB device, connect. You'd have to mess about with the boot button because we're not flashing it. So now if you push the reset button on the ESP, we'll see all sorts of stuff printed, but you should see this bit here. So this is printed by the library that talks to our controllers. If you see this, that means it's running, and happy days. And yeah, to be honest, that's it really. Yeah, so I'm not too sure what we're going to talk about next, but we'll figure it out and move on to the next bit. Right, so let's recap. What have we got so far? So we've had a demo of it all. We've gone through the hardware and how you can make the hardware. We've shown how to flash the hardware. So now you need to get the tech demo onto the PSP. So to do that, you will go to the tech demo repository and go over to the releases. So as of filming this, I haven't made this release a real release, it's a pre-release, but you will see the full proper release by the time this video goes out. I just haven't updated the release notes yet because I'm lazy. So you would click into this release and you would see this folder, PSP Bluetooth Tech Demo. So you need to download that and then open it up in your file explorer. So obviously, again, I'm on Linux, so this is a bit different, but you'd essentially extract that and you'd end up with this folder. So that folder in its entirety needs to go into your game folder on the PSP. So if we right click and copy that and connect your PSP however you normally connect it to your computer so you can view its memory card, which I've got here. So you'll go into the PSP folder, go into game, and you will just paste that onto your memory card. There we go. And that's it. And then you will safely eject and jobs are good. And now that will appear in your XMB and then you can select it like we saw in the demo. So I think that is everything. So I'm probably going to go over to a nice video of me on my face so you get to watch me talk, and then we'll have a little closing chat. Right, so I think first of all, thanks if you've stuck around this long. I don't normally make videos, as you can probably tell. So the quality isn't amazing, so yeah, I appreciate you staying to the end. So let's recap and go over, what we've chatted about. So this PSP Bluetooth is split across multiple projects. We have the hardware, which we've seen, where people can make their own boards, but they've also got prototypes for you to just start working with now. We've seen how to build them using PCBWay. We've seen the firmware, so the thing that runs on the ESP32 that deals with talking to the controllers. And we've seen the tech demo, which is the PSP app that shows you what can be done. So you might be looking at all of this thinking, okay, that's cracking, but I'm not a developer. I'm not writing homebrew that might make use of any of this stuff. I don't really care. I just want to use Bluetooth controllers. And unfortunately for you, there kind of isn't anything just yet. I'm working right now on taking the stuff I've done in that tech demo and putting it into a plugin that you can run in the background if you have custom firmware, and it will use some of that functionality to allow you to use Bluetooth controllers with all of your games. The good news is, because I've gone through this process first, I've worked out all of the bugs, I've worked out all of the issues and got a stable solution. So I'm hoping it should be quite easy to pull all of that out and plug it into this plugin and make it, you know, work. And it shouldn't take too long to get to that point. And then I'm hoping I can then expose ways of allowing homebrew developers, like the people doing the Perfect Dark port and, you know, things like that could use that extra functionality. So they could use multiplayer if they wanted to. They could use the vibration. They could use the LED colours and all that sort of stuff. So really, I think this is about it. There's lots coming up. I'm going to try and do more videos, but the likelihood is I won't do them until big gaps like I did with this one. But, you know, you can follow me on Twitter and all of them, and I post updates on there. Or the best way is to follow me on Github, and then you'll see the code changes I'm doing as I'm doing them. But yeah, that's about it. So, okay, yeah, cheers, thanks, bye-bye.